Okay guys, this video here is going to serve as a quiz, a review, a test, an assessment of your learning, whatever you want to consider it. But we're going to look through a lot of different questions. I'm going to load this up with some questions for you to answer here, multiple choice. And everything on your test on Friday is going to be here because it's everything we need to do in order to meet the learning goals that we've been working on this week. So I'm going to write up here the 6 basic graphs. Y equals x, y equals x squared, y equals x cubed, y equals absolute value of x, y equals the square root of x, and y equals 1 divided by x. Okay, so just remember when you're creating a t-chart, if necessary, or if you're trying to find some points that fall in this line, you can pick any x value you want. It doesn't matter. So in the world of xy coordinate plane, your x values would be here on your horizontal axis. We're just wondering, hey, when I'm at a specific point on the x-axis, where's the graph going to be at? So we know that y equals x makes the shape of a line, but we're curious, hey, when we're at -1 or -2 or -3 or some value of x, what's my output going to be? Okay, so that graph is relatively simple because there's not a lot of calculations, but if you need to pick some or find some coordinate points and you plug in -1, 0, 1, and 2, plug them in, so y equals -1, y equals 0, y equals 1. Okay, relatively straightforward. Same thing when you're working with x squared, for example. Okay, so I'm not going to do necessarily all of these. I'm just doing a few of them. Plug these in. Use your calculator if you need. Use your what you remember about the equations. Shoot, I would even say, hey, use numbers that aren't going to trip you up. Numbers that aren't going to confuse you. Okay, so maybe we get rid of the -1. We just say 0, 1, and 2. Okay, because those are easy numbers to multiply by themselves. So 0 squared, or 0 times 0, 1 times 1, 2 times 2. Okay, and it's relatively simple. All right, so don't make it harder than it needs to be. Don't use negatives if you don't feel comfortable. Same thing. Let's jump down here to the square root of x. Pick numbers that you are comfortable with. So maybe you pick 4, 9, and 16. Because you know the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Okay? So pick numbers, input values, or x coordinates that you're pretty comfortable with. The next portion of the learning goals that we need to be able to do is take a graph and graph it based on what we know about translations without using our calculator. Okay? So if I put a few up here as an example, or 2, and let's do one more. Okay, so this first graph here, first thing you need to do is identify what is the base graph or the parent graph. And I see I've got these absolute value symbols, so I know the base graph or the parent graph looks like this. It makes the V. Okay, the next thing I need to do is decide, hey, is this moving left or right? Is it moving up or down? Okay, so I graph the base graph in red just for temporarily here. I see the number with the x. I know since it's with the x, I'm going to have a translation on the x-axis or a horizontal translation. I'm going to move in the opposite direction of the sign. So this graph here, if I could grab this with my pen or my hands and just shift this whole thing to the right 5 spaces, that's exactly what I would want to do. Okay, so I'm going to delete it since I can't actually grab it. Shift 5 spaces to the right and put a point there. What that point represents is my point of origin. So instead of 0, 0 being right here and I draw my graph, now we're going to shift it over and say, hey, my new origin is over here. Okay? graph my absolute value function, my V shape, and be done. Okay? When you're doing this, it'd be nice if it was perfect and it was exactly where it's supposed to be, as long as it's close. It's really all we're after, as long as it's real close, within reason anyway. Alright, next one here. Again, square roots, that's a really distinguishing feature there of that graph. So I know that's going to make the swimmer's arm. Going to identify here with the x again, opposite direction. So instead of moving positive 3, where it says plus 3, I'm going to move the other direction. So I'm going to go left 3. And then this number that's with it, it's not inside there with the x, but it's outside here, is going to move in the same direction vertically. So think about on the vertical axis, a -2 would be going down. So I'm going to go left 3, down 2, and put a point there. Whoops. And then just sketch in my swimmer's arm. Alright, the last one here. Again, looking for distinguishing features. X squared, I see I got this exponent right here. That's a big key, that's going to make a parabola. Again, look at my translations. Left 5, same direction here, up 3. Go left 5 on my x-axis, always starting from the origin. Every so often I get people that are asking me, well, where do I start at? You're always starting at the origin, and I'm grabbing that point, moving left, going up, and then my parabola, clean that up a little bit, my parabola is going to go through that point, something like that. Okay? Now let's take a look at another scenario. Let's say instead of having the equation and then identifying the graph like I did in these three, so we sketch a graph, what if I started with the graph? Okay, so let me draw a graph. Let's start with maybe this one. So I just sketch a picture in there. Again, it's not perfect, but get the idea. Now I want to write the equation of that graph. Okay, so again, my process is going to be the same. First, let's identify what equation I'm going to use based on the shape. Okay, so I see I got this curve to it, and we're going to remember that's called the cubic curve. So kind of a hint there, the cubic, it's x cubed. Same process again, decide did it move left or right? Okay, well it moved left. Alright, and how far? It moved 1, 2, 3, so I went left 3. And then I didn't move up and down, just left 3. Okay, so I know that that's going to be a horizontal translation. The number is going to be in here with the x, and it's going to move opposite direction of the sign. So I'm going to do x plus 3 cubed. And that's the equation of my graph. Alright, let's take a look at another one. So let's do this graph here. Let me sketch this graph, what it's going to look like. Okay, something like this, and then, let's see. Alright, so again, let's repeat the process. Let's take a look at my base graph, and I recognize that's the inverse function, so it's going to be 1 over x. And now let's do a little bit of looking here to see if I move left, right, up, or down. This one's a little bit more challenging because it's the only graph where that doesn't pass through the origin. So if I slide over here, try to find kind of a middle point on this graph, I remember that this point here was originally on x1, y1, and this point here was originally on x -1, y -1. Okay, so I remember those 2 points were important, and then right in the middle was my origin. Okay, this isn't the origin anymore, it's a special point, but it's serving as my origin in relation to my base graph. Okay, so if I look here, I went 1, 2, 3, 4, so I went right 4, and then from there I went up 1, 2, 3. Okay, So let's hop over here to my equation. Horizontal shift goes with the x, so 1 over x, and then instead of going positive 4, we want the opposite sign here, so 1 over x minus 4, and then here we're going to have going up 3, so the same direction of the sign. Alright, so also realize there's two forms we worked with. The one I wrote here is what I'm assuming most people are going to use and what I've seen in class. But just for the sake of the example, I could also have done y minus 3 equals 1 over x minus 4. Okay, so just kind of on the idea that I could have subtracted 3 from both sides and ended up with this equation. Alright, so either one of those would work. Alright, one last one here. I'm looking at the time. I'm not trying to make this super long, but I do want to get another example in. Let's take a look at one that's a little bit easier to see. Okay, and I didn't really mention this, and maybe it's been a lack of a focus in class, but we're putting arrows on the end of our graph here just to represent the fact that it's continuing on. Those lines are continuing on in both directions. Okay, so base graph is the absolute value function. I see the V, and that reminds me of the word value. Okay, so let's count out our translation. 1, 2, 3, 4. So that went left 4, and then down 1, 2, 3, 4, 5. Down 5. Okay? Hop up here to my equation. Horizontal shift goes with the x, opposite direction. So x plus 4. Vertical shift goes outside of the x, or outside of your symbols here, same direction, so minus 5. And then again, some people like to remember that number with the x is horizontal, opposite direction. So if it's with the y, it's going to be vertical, opposite direction. Maybe that's easier for you. I honestly can't tell you which way to do it. I can just tell you here's the two options. You go ahead and make sense of which equation works best for you. Consistency usually helps people, so if you stick with the same form all the time, you'll be in good shape. But again, that's a personal decision. All right. So maybe just looking at the time, and I know the review will be beneficial to a lot of people. So let's look at one more situation. What if I just gave you a problem and said, "Hey, here's my equation." Go ahead and describe the shape and the direction that I'm going. Okay, well, if I'm just describing it, it's going to be a swimmer's arm. I'm going to go left 1, and I'm going to go, left 1, and I'm going to go down 7. Okay, let's look at another one here. I don't think we've done this one much yet. Okay, so a lot of times this one throws people for a loop because there's no square root sign, there's no absolute value, you don't have the fraction, there's no exponents. Okay, well that only leaves one option. It's got to be the line, and we're going to go left 8, and then we're going to go down 2. Okay, we'll call it good there for review. You're getting feedback as you go through here on your multiple choice questions, so you have a really good idea of where you're at. Again, getting more feedback. Use that to your advantage. If you want to rewatch the video, that would be great. If you want to look at your notes again, and remember, you can email me, you can stop in during seminar. Math lab, 3rd period is my seminar, 7th period math lab. You have lots of options to do that. All right.